All right, here we're starting part 2 of the similar polygons notes. So quick warm-up problem here. Are these triangles similar? So bear in mind the definition of similar polygons, kind of two properties we need to make sure to check on. One, are the corresponding angles, are those congruent? Check that. And then two, whether these sides are proportional. Proportional. So do they make equal ratios? So those are the two questions we need to answer here. So feel free to pause, work through this, make sure to check and see if these are similar. And then I'm going to go ahead and go through it. All right, so let's start with the angles. You could go either way. I'm going to start with angles here. So I have 38 degrees, 54 degrees. So let me just find out that last one. 180 minus 38 minus 54. So that leaves me 88 degrees for this angle right here. And then over here I have 180 minus 57 minus 85. Okay, and that leaves me 38 degrees here. So quick check, this is kind of interesting. Let's go ahead and go through the angles that we have. We have 38, 57, and 85 in this triangle. Those are degrees, obviously. And then in this triangle, we have 38, so one congruent one, 54, and 88. So close, but not all of these angles are congruent, right? We have one congruent pair here. These are close, but the answer here would be no. Our angles are not congruent. So that's already enough. These are not similar triangles. But let's just go ahead and check out the sides as well, just in case, maybe maybe the sides were proportional, but the angles weren't. So let's just take a look at the sides here. We want to match up corresponding sides. So since we know all the side lengths of each of these triangles, I think the easy way would be to just match them up according to shortest side goes with the shortest side. Oh, so if I write a ratio there, that's 24 feet over 48. That one simplifies to be 1/2. Okay, 1/2 is a good ratio. Then my middle side here, the middle length is 33, and the middle length over here would be 63. Let me try that again, 63. That's this side. So those two would go together, 33 over 63. So that sort of is close to 1/2, but if we reduce that, we can divide those by 3. That's 11 over 21. So really close, kind of like these were close, but not proportional. And then let's just write the last ratio out just to compare those as well. 39 over 78. So 39 over 78. That actually is 1/2. Those are both divisible by 39. So two of our ratios were good, but the third one sticks out. That is not an equal ratio. 11 over 21. So not proportional that way either. So no, not all the sides are proportional. So these are not similar triangles. All right, so we're going to take a look at 3 practice problems involving triangle similarity. So, yep. First one here, we have some overlapping triangles. It is given to us that they are similar, although in the future we could demonstrate that without this statement. But anyway. The similarity statement does let us know which parts correspond to one another. So angle B goes with angle B. Angle A here goes with angle D. And angle C and D correspond. So the similarity statement can kind of help you figure out what things correspond if it's not super obvious to you. The goal of our problem is to solve for x. So we need to use this expression in an equation in some way to solve for x. In this case, since we have similar triangles and our variable is part of the sides, we know that the sides of similar triangles are proportional. So we will be setting up a proportion. X plus 15, let's go ahead and put that on the top of this one. The side that would correspond with is the 15, with that side right there. So ED and CA would correspond. We can kind of see that either in the similarity statement, ED, CA, or we can kind of look at the angles that are there, or just kind of visually see that they're in the same position. And then we have this side over here. So the side of our big triangle is actually this whole length here. It's 40. So that needs to go on top. And then the side of our shorter or smaller triangle here is 30. There's a lot of temptation. People will use this 10. They'll do like 10 over 30 or 30 over 10 or something. That 10 is just a piece. That's not a full side length. So, I had to use it to come up with this measurement, right? Adding these two parts together to get 40, but it's not a value that needs to be used in my proportion here. Anyway, once I have this, I can go ahead and start solving. Notice that this proportion is set up with consistency. The larger triangle is on top, and the larger triangle is on top, and then the smaller one is on the bottom in both of these. Another thing to note is you could simplify this fraction first before doing cross multiplication, but you don't have to. There's no reason you have to, but it would reduce the numbers that you're multiplying by. So instead of multiplying by 30 and by 40, you'd be multiplying by 4 and 3, much smaller numbers. So that is a useful thing to notice, but not a big deal. It doesn't really matter, especially if you're going to use a calculator. So we get 3 times x plus 15 equals 4 times 15, which is 60. And then we're just sort of off to the races here in terms of solving this problem. Subtract 45, 3x equals 15, and then divide by 3. So x equals 5. Great, awesome. That's all we had to do for this problem. We could use that value of x to figure out this side length, right? 5 plus 15, so this side is 20. But that's the answer we're looking for, x equals 5. Okay, let's go ahead and clear this, move on to the next example. So here we go, we have another set of similar triangles. So in this case, the similarity statement is going to be pretty useful. These triangles are kind of oriented weird, and it's sort of an overlapping situation, except you'll notice that we don't have any parallel lines, so we can't use the same ideas that we had before. So let's just kind of match up the angles with each other. So angle D and angle C. So angle D in triangle DEA. So DEA is here, DEA. So angle D in that triangle is going to correspond with angle C in triangle CBA. So CBA. So that much larger triangle there. All right, so let's match up the parts as I was starting to go on. So angle D corresponds with angle C. Those are going to be congruent to each other. Angle E corresponds with B. So angle E here corresponds with angle B here. Okay, they're both right angles. That makes sense. And A goes with A. All right, and this is a shared angle here for both of the triangles. So the orientation is a little strange, kind of where they match up and what sides are going to go together. So some people might like to take that red triangle out and kind of draw a new copy of it just with a similar orientation. So they might draw something like this for themselves and say, all right, let's put that right angle on top so that it matches this a little better. That's E. Let's put that single mark angle down here. That's D. And then that double mark angle, that'll be A. So just kind of like recopying things out in a slightly different orientation, sort of reflected around or rotated, just so it looks a little more like that. You can certainly do that. It doesn't really matter. And then labeling it to sort of go with it. You can use something like this if you want, or you can just kind of use the angles and the sides to kind of help you out there anyway. All right. So again, our goal here is to solve for x. I think this is the harder of the 3 examples that we're going to go over. So x is right here, but this is not a full side of one of my triangles. So I actually need to use that to kind of create an expression that represents this whole side. So this whole side would be 2x plus 3. Add those two lengths together, we get the whole side. So that's the one I'm going to be using in my equation, that whole side length there. and that goes with side CA. So side CA, that's supposed to correspond with DA, so DA. So that corresponds with 5. So that's really good. And then I need to figure out 2 other sides that correspond. So I know this side of my bigger triangle, BC. So BC is supposed to correspond with DE. We can see that in our 8. BC, DE. Or we can see that in this picture here as well. So 8 corresponds with 4. Keep in mind the consistency here. I put the bigger triangle on top, smaller triangle on the bottom, bigger triangle on top, smaller triangle on the bottom. You got to make sure you have that consistency. Similar to the last one, I actually could reduce this ratio to 2, 2 over 1, if I wanted to make this a little bit easier. So we have 1 times that. 1 times anything doesn't even do anything, but that's okay. 5 times 2 is 10. You can keep the 8 and the 4 and just use the cross multiplication with that too. That doesn't really matter. Just let's reduce if you can. It's a smaller number. Anyway, 2x plus 3 equals 10. We'll subtract 3. We get 2x equals 7. Divide by 2. Divide by 2. We get x equals 3.5. Easy enough, 3.5. So that's all we had to do. Again, we could use that value of x to kind of plug it in here and find some stuff out, but we're just solving for x. Oh, last example here. So number 3. So in this case, we have these are 2 triangles that are created by some transversals. So we have our parallel lines here and here. Those are parallel. And then we have these transversals. So we have a transversal here from D to C, and from A to E. So those are transversals. The reason that's important is because that does create things like alternate interior angles. So here and here, and here, and here, those are alternate interior angles. And also we have these transversals that cross one another to make these vertical angles here. So we can kind of identify all the angles that go together that way, or we could go ahead and look at the similarity statement that we were given. So A corresponds with E, A, E. We already marked that. B, B. Yeah, vertical angles there at B, and C, D, C, D. Yeah, we already marked all those things, but similarity statement or using that information we know there. Either way. The other great thing about here is we've actually already identified the corresponding sides just by sort of color coding it. Like the purple sides go together, 12 and 18. You can take a look at the angles to help you identify that, right? So for instance, 12 is in between the single mark and the triple mark. 18 is also between those. So those sides correspond with one another they're in the same position. All right, so keeping in mind that our goal here for this problem is kind of the same as the last 2 that we've been doing. We're trying to write and solve an equation for x. We're talking about the sides of similar triangles. We're going to need to set up a proportion. So I want x involved in it, obviously, in order to solve it. So x plus 1. That's going to correspond with 24. Those obviously correspond. They're the parallel sides, and they're between the same kind of angles. And then I need another set that corresponds, so 12 and 18. Again, remember to set this up consistently. I did the smaller one, the one on the left on the top, and the one on the right on the bottom, left on the top, right on the bottom. Make sure you have that consistency. And once you have your equation, it just becomes a matter of solving it. So again, I can reduce this, might as well. These both reduce by 6, so that becomes 2 over 3. And then we can do our cross products. 3 times x plus 1 equals 24 times 2. And there we go. 3x plus 3 equals 48. Subtract 3. Subtract 3. And that gives us 3x equals 45. Divide by 3. We get x equals 15. again, we can use that value of x, kind of find some stuff out, but goal here is just solve for x. All right, so catch up on your homework, catch up on the news. We'll talk about this stuff next week, but remember triangle congruence. This is just kind of a quick reminder. There were some 5 shortcuts that we learned about. They were SSS, SAS, ASA, AAS, and hypotenuse leg, the one that sticks out differently. So anyway, we're going to learn some triangle similarity shortcuts is our next section. Hopefully these sort of ring a bell. Anyway, have a good rest of your day, guys, and see you later.